Welcome back to my channel. In this video, I'm going to discuss about the Codeforces contest 946 Division 3. The problem is fifth one. The money buys happiness. I'll just read out the problem statement before going to the solution. So it begins by saying that being a physicist, Charlie likes to plan his life in simple and precise terms. For the next M months, starting with no money, Charlie will work and earn X pounds per month. And for the ith month, and there will be a single opportunity for paying CI pounds to obtain happiness HI. So basically, it says that we have been given a number of months as M, and for each month, and he will be earning X pounds per month. That also will be given, how much he will earn per month, and for each month, he can buy happiness. For ith month, the happiness will be HI, and the happiness doesn't come for free. The cost of the happiness is for that month is CI. Now, the cost of the happiness for the next month will be different since C1, C2 need not be same. Borrowing is not allowed. Money earned in the ith month can only be spent in the later jth month. I see. So they are saying that the money earned in the current ith month can only be spent in the next later jth month, like the next or any other subsequent months. For example, if you want to buy happiness HI for that ith month, you can't buy with the money you earned in the ith month, but you can buy the happiness HI with the money you earned till now from the previous months from 0 to I minus 1. So many months you have earned, right? That total sum you can be used that can be used to buy the happiness HI for that ith month. So we need to find the maximum obtainable sum of happiness. So whenever you see this word maximum, so the only concept that should ring in your mind is DP. So this problem is solved using the dynamic programming. If you see the list of problems, the fifth problem also is about money buys happiness, and the last problem is also about the money buys less happiness. So the difference between these two problems is that the constraints in fifth problem is bit less, a bit smaller than the constraint in the last problem. So in this problem, I solved it using the uh, memorization approach of the dynamic programming, which means the recursion, and the better version of recursion is called memorization. So let me go through the test cases. They have been given first line is the T, which is the number of test cases that will occur. 7 means you should understand that there will be totally 7 test cases. And next, night will cover the M and X, which means the number of months and how much he will earn in each month. And next line will have the M lines. If it depends upon the M we are getting in the second line, it will have the following M lines with each two integers CI and HI, the cost of happiness in that month, and happiness, how much happiness he can buy in that month. So in the first test cases, there is only 1 month. So the following there is only one for he the cost of that five happiness is only £1. So in the second test there are 2 months. If you see here, the cost of 10 happiness is £0, and the cost of 100 happiness is £200. In the first month, cost of 10 happiness is £0. Cost of 100 happiness is £200. So basically, what we have in the DP here is DP is basically a choice. So either he will buy this thing or he won't buy the happiness in that ith month. It's totally up to him. Only thing is that we need to put the maximum constraint in the code, and it will give you the magical answer. So if you go to into the code, if you see here, I'm just trying to get the inputs after the test cases here. And first one is the n, x, and I, and n and x will stand for the number of months, and the number of the how much he will earn in the each month. And next followed by the C of n vector and h of n vector, where c of n will store the cost of happiness in each month, h of n will store the number of happiness that I can buy in that month. So, and after this, I will be creating a vector VVLL. I have defined in a type def, which is VVLL is a vector of vector, which is here SP and DP. Here DP is basically the dynamic programming. Basically, I'm initializing it, but here SP is not a dynamic programming. It's basically uh, minimized version of the dynamic programming, which stores that and for that particular month and what is his earning, whether his earning is cost of that more than the cost of happiness in that month. Only if it is more than the cost of happiness in that month, then only he can buy the happiness. So if it is less than the cost of happiness in that month, and even after solving the main DP problem, it will be of no use. So pass everything into the DP function. After passing, just write the base condition. You will start with the first month. Once you reach the final month, just check whether the cost of happiness is less than your total income, how much you have saved till now. If it is less, then buy the happiness, because you won't be, there is not an option that you won't buy the happiness in the last month. If you have come across like without buying the happiness till the last month. Why? Because the problem states that we need to maximum sum of happiness. Something is better than having no happiness, so we will either buy the happiness if the cost of that happiness is less than your earning, or if it is more than your earning, we won't be able to buy, so initialize it in zero. So as I said, just have the two test cases, whether you will take the app whether you will take the happiness or you will not take the happiness. If you didn't take the happiness, then just move on to the next month and not updating any other array. But if you are taking the happiness, but take the happiness if and only if the current savings is more than the cost of that happiness in that particular month. If you are taking that happiness, then update the happiness with that current month happiness, and or subtract the cost of happiness from your savings, and just return the maximum of whether you are taking the happiness or not taking the happiness in each case. Thanks for watching this video. Thank you.